So we've been looking at vectors, and we've been looking at vectors that are two-dimensional. They have an X and a Y. What we're going to look at today is something kind of interesting. We're going to look at 3D vectors. So that means it's three-dimensional. That means we have an X, a Y, and a Z. So in this drawing, this is the X-axis, this is the Y-axis, and this is the Z-axis. So let's kind of fill them in there, X, Y, and Z. So you have this three dimensions. Think of this one as coming out of the page, kind of. So if I was drawing this one, I would come out 5 steps on the X direction. 1, 2, 3, 4, 5. 4 steps in the Y. 1, 2, 3, 4. And 3 steps in the Z. 1, 2, 3. Now the easiest way to find where this point is, because it's way out here somewhere, way off the page actually, is to kind of make a little box. Okay, so this back panel would be like this, and we'd have, let's see, it would go, this one would go 1, 2, 3, 4, 1, 2, 4 that way, so kind of like this, and then it'd go up, up. So I'm kind of making a 3D box. The point 543 would actually be way out here. It'd be off the page. Now, what we want to be able to do is work with it. We want to find things about it, like the magnitude, the length. Well, when it was just an X and a Y, we'd find the difference in our X's, square it, the difference in the Y's, and square it. Well, we're just going to add on the difference in our Z's and square it. Back when we found midpoints, we would average our X's and average our Y's. Well, if we have 3 dimensions, we're also going to average the Z's. So let's look at finding the length and midpoint of the vector with the given initial and endpoint. So remember, order really matters. This is my X1, Y1, and Z1. This is X2, Y2, and Z2. The order really does matter because initial and endpoint. So the length, and I'm just going to call it vector V, the length would be the square root of the difference in the X's, so -9 minus 6 squared, plus the difference in the Y's, -10 minus 1 squared, plus the difference in the X's and Z's squared. So that gives me, let's see, that would be -15 squared, -11 squared, -14 squared. And so let's see, that's 225, 121, 196. And then I would add all those together. So I'm going to grab my calculator off to the side. And I get 542. Now to find the midpoint, we're just going to average the X's, average the Y's, average the Z's. So that means when we average, we add them and divide by 2. Then we're going to add the Y's and divide by 2. Then we're going to add the Z's and divide by 2. That's how we find a midpoint. So this gives me -3 over 2. And then that's -9 over 2. And that'd be 6 over 2. And that's the midpoint. Now for the video, I'm going to skip the next example. In class, I would have you work on example 2 and check your answer, but I'm just trying to get the basics in here. Component form. When we had just X's and Y's, component form, we found the difference in our X's, difference in our Y's. We just added one more component. So this is A to B. That means A is the starting point, B is the ending point. So that means this is X1, Y1, Z1, x2, y2, z2. So to write it in component form, we're going to find the difference in our x's. So that'd be 11 minus a negative 5. And then negative 3 minus a negative 5. And then negative 1 minus a negative 9. Now remember, when you minus a negative, that becomes a plus. So that's going to be 16. Negative 3 plus 5, that's 2. Negative 1 plus 9, that's 8. Find the component form of vector AB. So try this one on your own. And you should get, so pause it, try it, negative 4, 8, and 20. All right, moving right along. So the next thing we need to be able to do is super easy. We're just going to write in the different forms. It says to graph. I'm not worried about graphing. I'm just going to write it in the different form. So if it's written with I, J's, and K's, remember when it was 2, we just had an I and a J, that kind of represented the X and the Y. Now we have 3. So component form would be 6, 8, negative 2. If I rewrote this one in linear combination, that'd be negative 1I plus 3J minus 4K. We just have one more in there. Unit vectors are found the same way they were when it was 2. You take the vector divided by its magnitude. So we have vector AB. So I'm going to come over and find the magnitude of AB. And that would be the square root of, oh wait, that already gave me the component form. So I already know that this is the difference in my x's. 1 is the difference in my y's. And 4 is the difference in my z's. So that'd be 4 plus 1, 5, plus 16, 21. So to find a unit vector, and they're calling it U, we take the vector divided by its magnitude. All we're going to do is divide each component by its magnitude. Next, we have another example of finding a unit vector. Pause the video, find the magnitude, and then find the unit vector. So you should have gotten that the magnitude is square root of 26. So our unit vector would be negative 4 over the square root of 26, negative 3 over the square root of 26, and 1 over the square root of 26. Now, vector operations, oh my gosh, they all work just the same. It's just we have another component. So, 5a minus 3c plus 2b. That means I'm going to take 5, see, I can actually write this as 5a plus negative 3 times c plus 2 times b. That's what I'm going to do. I'm going to multiply vector a by 5. Then I'm going to multiply vector c by negative 3. That'd give me a positive 12, negative 6, and a positive 15. Then I'm going to multiply vector b by 2. Then we're just adding them all together. So negative 5 plus 12 minus 4, that's 3. 10 minus 6 plus 6 is 10. 15 plus 15 is 30. Minus 8 is 22. All right, so 2a plus b plus negative 3c. So 2a plus b plus a negative 3 times c. So that'd be 12, negative 6, 15. I'm going to add those together and get 8, 1, 17. Now, I forgot to add this last example, and that would be to do a dot product. And when we do a dot product, we're doing only 2 together. So we multiply a and b together. So that's taking the x components and multiplying them together, plus the y components multiplied together. But now we also have our z components. So that gives me 2 plus 6 minus 12. We get a scalar, we get a single number of negative 4.